Hello and welcome to the webinar Value Stream Mapping with mpmX. My name is Florian Stich and I'm going to show you today how we can do value stream mapping in our solution mpmX and what the advantages in comparison to the conventional approach are. Value stream mapping is a visual mapping method to analyze and optimize business processes. The goal is always to make the processes more efficient and to reduce waste. This technique is part of business process modeling and was originally developed as part of the Toyota production systems in the 50s and 60s. And it was strongly adopted by the industry in the 80s and 90s, especially in the lean manufacturing sector. So this method is used already for many years in companies in order to optimize business processes. And right now I have an example for you to explain value stream mapping again. So imagine we are a producer of car doors and we have our customer, the automotive industry, and our customer orders in monthly intervals, and the order goes to our office, and we go to our supplier and say that we need raw material. So those are the information that flow, and the material that flows looks like that it comes in by a truck from our supplier, all the raw materials. They sit around in our warehouse until the first actual production step, the preparation and pickling, is done. Then other production steps like galvanizing, painting and coating, packaging are executed. And in the end, the product, the finished door, gets delivered to our customer, the car producers. But where in this process is now the actual value adding time? That's what we can find out when we take a look at the lead time ladder. So first of all, the product comes in our warehouse. Of course, we want to make sure that we always have enough stock, but the product is sitting around there for 3 days before the first actual value adding process step, the preparation and pickling, is done. The preparation and pickling takes an hour. It sits around there for another day until it goes to the galvanizing, which takes 2 hours, and so on. So this is our lead time ladder, and we can see that there's some value adding time, but also non-value adding time where the product is just sitting around there between those production steps. The overall lead time then in the end is 9 days. That's the time from the raw material coming in our plant until the finished product arrives to our customer. But the actual processing time is just 7 hours. So dividing those 7 hours by those 9 days will result in an actual value adding time of just 2 or 3%. And of course, we want to increase that value adding time to reduce those times in between the process step to enable a smooth production. And that's what a value stream map is there for. However, those value stream maps require experts that go into the production, they take times, they follow one product and see where the waiting times in between the process steps are. So it's very resource intensive. And you need experts that know how to create value stream maps and know how to gather all that data manually. As I said, the experts go in the plant, they take all this data, they see where the product is going. So it's just a one-time record. So you don't have any observation over time. Especially nowadays in this world, there are many factors, also external factors, that can change processes, that can change different other things. So you don't have that observation over time, and you cannot see it for every production order. What happens is just a one-time record. And in addition to that, there is no real context information in such a value stream map regarding, for example, the type of raw material that comes in, or if you produce several different products in your plant, those information are missing, information about the customer as well, for example. And that's what we can solve with our solution, mpmX. So the illusion about traditional value stream mapping is that you have the map and that it shows you how the process is really taking place. But in reality, that can look different. You can see it here on the production layout, which comes from our solution. All those different ways the production orders go in our plant is what is represented right here. And that doesn't look that straightforward. And you can see there are many deviations occurring. So with our solution, we can show how the process really looks like. And as it's completely automated and based on data, it's cost saving very fast and integrated into your IT system landscape. But how does our technology actually work? So we have different processes in companies. Right here, there is a very broad picture of such a production process. So the raw material gets shipped in. We get that information from the SRM. Then there are different production steps. Those are all machine data that we are gathering. And in the end, it's delivered to the customer. That data can come from another system again. From all those data, the digital footprints, we derive event logs. And on the bottom, you can see such an event log. So there is the production order, which is a clear identifier of one process instance. And in each production order, there are different process steps occurring. So, for example, the pickling, rinsing, flux bath, and so on. From each of those process steps, or how we call them here, activity types, there is a timestamp. And with those very essential information, we can already visualize the process. And that is happening fully automated by our algorithms. Once we have those process variants visualized, we can see how the process steps actually took place and what time passes in between each process step. We can also detect rework process steps or other inefficiencies, and like that we can target our optimization. This is how it looks like in companies at our customers. So many companies have very heterogeneous IT landscapes. There are many different processes happening in companies, not just production processes, but also the caching processes or procurement processes. And all of them are handled in one or many IT systems. And what we do with mpmX is that we can orchestrate all of those processes end to end in our mpmX analytics part. And with this digital process twin, we can see where there are inefficiencies in the processes. And with the mpmX execution module, we can then really optimize the processes and create value. So if we, for example, see that in certain processes, steps are done always manually, but they can be done automatically, we can automate that with mpmX execution. Or if, for example, in a production process, we detect any critical foreseen process steps, we can inform the process specialist automatically via mpmX execution. And that's how we can solve actual problems or even prevent actual problems. How that looks like in our tool, I'm going to show you now in the live demo. So let me just switch right here. And we are starting very simple again, just for your explanation. So right here, we have the event log again. I've selected now just one production order, the production order 1511. And there are different activities for this production order. We have the timestamps, and like that, we can visualize just this one production order in our so-called process analyzer. With the timestamps, we can calculate how much time passes on the process steps, so what the processing time is, and what the waiting time in between those process steps is. I can now also select another production order, and we will see this one now also visualized in the process analyzer. So I hope the rough concept of how our process analyzer is visualizing each production order is clear. But what we do now is, of course, not to look just at one or two production orders, but at all 23,600. And I'm just going to display here the most frequent variant of those 23,600 production orders. You can see that 600 production orders follow exactly that path, how it's visualized here. And of course, I can show more process variants. For example, now I'm displaying the second most frequent process variant because here a quality check and rework occurred. And like that, I can show more and more. And I would say we're just showing now maybe the top 10 variants, as this is still good to capture for the human eye, and we have a more representative picture of roughly a quarter of our production orders. Now I want to focus your attention on the KPIs on the left as well. There are KPIs about the average lead time and idle time, so the time that passes in between those process steps, and very interesting, our activity ratio. The activity ratio is basically the real value adding time we were talking about before in the value stream map. So 1.19% activity ratio means that in comparison to the whole lead time, the actual processing time of the production steps, the real value adding time is just 1%. And of course, we want to increase that because we don't want to lose a lot of time in between the process steps. I will now show here in this bar chart my products, different products, and I can see what the activity ratio per product is. So like that, we can already gain insights into different context information. For example, I could also now just filter on the product with the highest activity ratio. And all those KPIs and also the process analyzer on the right side get recalculated. It affects 1,300 production orders. And right here, I can now analyze how the top 10 variants of those production orders occurred. So, also very interesting is that we can visualize the production orders not only in our process analyzer, but also on production layouts. That's what you can see right here. So we have now displayed the top 2 variants in our process, and we can see that on the production map. So we have all those different stations like galvanizing, pickling, and so on visualized here on this map. And we can see the actual flow of our production orders, but just the top 2 variants. If I show more variants, this looks already more messy. So now you can see all the different ways that our production orders went. And we can zoom in also and have more information about, for example, how much waiting time passed from the flux bath to galvanizing, and how often it passed. So the thicker the arrow is here, the higher the frequency of products that went from one station to the other. And we can clearly also see that there are parts where in our production plant where the production orders move back and forth. So we could think about reallocating some of the machines to enable a smoother flow. Also, a big advantage of this production map in comparison to conventional value stream maps is that we can filter in our data. So we could just, for example, show a value stream map of one product, of this one, for example. And now, as you can see again, all those visualizations get recalculated, and we just see the flow of this one product. Also, we can see in our filters directly which raw materials, for example, are associated. So those gray highlighted raw materials are not associated with this product number, but just this ones. And we can drill down even more into our data by just filtering on one specific raw material now. Okay, so another very interesting analysis or very interesting KPI is the EPay analysis. EPay stands for every part, every inventory. So it describes how much time passes until we can produce the same product again or the same lot again. And in this case, the overall EPay is 1.59 days. So it takes us 1.5 days until we can produce the same product again. This is, of course, mainly influenced by the capacity of the machines as well as the setup time of the machines. We want to keep that rather low to have a smooth production and to be able to produce and plan our production very good and fast. In order to reduce that and in order to optimize that, we need to take a look at the different process steps, at our activities. And we can clearly see that the anti-corrosive packaging has a rather high EPI of more than 1 day. The setup time isn't actually too high if you compare it, for example, with the de-alloying, which has a lower EPI but even a higher setup time. So what we can interpret from that is that probably the capacity for the anti-corrosive packaging is too low. So we can work on that. If we now take a look at our process analyzer again, we can, however, see that the anti-corrosive packaging is not occurring in every case. So there are cases that don't even go through anti-corrosive packaging, but through different process steps. And that's why now we can also filter in the process analyzer to show all production orders that do not go through this activity. That's what I'm doing right now. And you can see that a little bit more than 15,000 production orders are affected by that. And also all our tables and KPIs get recalculated. We can see that the coding is probably the second optimization potential. And now we have already found 2 process steps, the anti-corrosive packaging and the coding, and we can get into the discussion with the responsible person for the production in order to optimize the EPay. What's also a very important topic in value stream mapping is the waste. So right here we have analyzed how much stock is just laying around before one production step. We can see that there are steps like delivered to customer or raw material reserved. This is before it's delivered to the customer. Of course, there's a lot of stock laying around there, or when the material comes from our supplier. So those are more the warehouse issues. But what we can definitely tackle is, for example, steps like sandblasting, drilling of hollow profiles, deburring, and so on, because also there we have quite much stock before the process step. The 2 reasons for that could be that either our machine, sandblasting for example, has too little capacity and cannot work on those parts fast enough, or that the machine before is producing too fast. And therefore, we have another KPI in our process analyzer. I would just unfold all those groups that we can see the process a little bit more in detail. And I will change to the KPI percentage of queued cases. Percentage of queued cases means that a part is queued even though it should be worked on already. And if we then zoom in our process analyzer, we can directly see that some of those connections between the process steps are thicker than others. That means that the KPI, percentage of queued cases, is higher. And we can clearly see that before deburring, there is a very high percentage of queued cases. So that lets us conclude that the deburring machine has probably too little capacity, and that's another improvisation potential in our process. I hope this demo helped to get a quick look at our solution and how we can improve on our production processes and what advantages it has in comparison to the traditional approach. Right here, all of those advantages are summed up again, even with results of what we achieved at our customers. For example, reducing the non-value adding times by 13%, or to reduce the operating costs per year by 400,000 euros. And those are results that we achieved, that we can also achieve for your processes. And in order to make that more simple, we summed up everything in business apps. So what I just showed you in our solution is already a pre-built analysis with prepared ETL, extract, transform, load ways. So all the data models are already prepared so that we can connect very fast to your production system and analyze the data and have all those analyses already prepared in order to see where we can improve your process. Here is again some examples shown where we can also improve the process actually with our mpmX execution module, what I showed you before in the slide. So if there are, for example, long dead times or transporting or waiting times, we can see this in a poor activity ratio for some of the context information that we have. Like, for example, for one specific product, the activity ratio is very critical, and our mpmX execution module can automatically inform a specialist about that once a certain threshold is reached. Or if there's, for example, rework in our process, we can see that in cases that have a very bad first time write rate, so a rate of cases that is not reworked on. And also for that, we can inform a specialist automatically. So our solution does not just serve to analyze the process and create transparency, but to actually make changes, to actually inform people in order to prevent certain problems in our process. If you now have any questions, you can use the panel on the right side or just contact us. For the questions that come in on the panel, we will answer them afterwards, but also if you want to have a deep dive session and talk about your system, about your process, feel free to contact us. And I hope this very short webinar could give you a good insight in what we can do with mpmX and value stream mapping. Thank you for your attention, and I hope to hear from you soon.